All right. So what we looked at yesterday and started looking at was completing the square. The first thing we did was finding a C value so that we can make a perfect square trinomial and be able to factor it to a set of parentheses squared, which helps us be able to solve. Now, this one here is one that we had on the note sheet yesterday. Yes? Because we had this one or a problem that looked like it. And this is the one we're going to start off with. And we're going to use the completing the square method that we found yesterday. And we went through yesterday to solve this. Because there are certain ones that are, if they're set up in a certain way, we can just go straight to finding the perfect square trinomial, setting it into a set of parentheses squared, and solving. But it might be sometimes hard to see that. So we can still use these kind of 4 steps, our main 4 steps we had yesterday, to still solve it. And the first step that we had was, is A equal to 1? And when we're talking about A, we're talking about the term, so ax squared plus bx plus c. We're talking about the term in front of x squared. So is the number in front of x squared 1? Yeah, so okay, so we're good with that there. It's 1. We don't have to do anything. Our next step was what? To get the constant term by itself and leave 2 spaces. Because again, we're moving the constant term so that I can make a trinomial, a perfect square trinomial with x squared and negative 16x. I'm trying to find whatever constant term is needed so that I can rewrite that into a set of parentheses squared. So what are we going to do to both sides? We need to subtract the 64 from both sides. Because when we do that, 64 minus 64 is gone. Plus, we still leave a blank for it because, again, we're going to find a value that's going to go there that will make that a perfect square trinomial that we can rewrite as a set of parentheses squared. Now, 100 minus 64 is 36. Move this over a little bit. Now, any questions over anything we've done so far? And yes, I do need a plus blank over here. So that was the first kind of main 2 steps. One, is A equal to 1? Yes. Put the constant term to the other side. Now we need to find the value of C for this spot here so we get a perfect square trinomial. So B over 2 squared. Well, what's the value of B? Negative 16 over 2 squared. Well, negative 16 divided by 2 is what? Negative 8. And negative 8 squared is? So isn't that what we started with? Yeah. So what that means is that our starting equation, x squared minus 16x plus 64, was a perfect square trinomial to begin with. It's one to begin with. So if, like this here, we didn't notice that this was a perfect square trinomial. Am I correct in saying that? Just looking at x squared minus 16x plus 64, we didn't really see that. And that's fine. Doing this here is kind of confirming, okay, this was one, which means we could rewrite this as x, what? Squared. So sometimes, even if you kind of notice it, if we do the completing the square, it kind of gives us a hint and tells us what it is. Any questions on this so far? Well, 36 plus 64 is 100. So it did work out that x squared minus 16x plus 64, our original equation, would have factored to x minus 8 squared. But doing completing the square got us to the same spot, didn't it? So it doesn't matter if it was a perfect square, a perfect square trinomial to begin with. We can still do our steps and get to the same spot. It'll work either way. Now what do we need to do? We need to square root both sides, because the square root and square cancel. giving me x minus 8 is equal to plus or minus. The square root of 100 would be 10. It did. And then our last step would be 2. We have to get x by itself, so I need to add 8 to both sides. And we get x is equal to 8 plus or minus 10.
Wait, why do we need plus or minus? I never asked.
So the square root of 100. We're saying we're trying to find the number multiplied by itself that gives me 100.
Oh, and that's 8 plus be negative.
Because negative 10 times negative 10 is 100. 10 times 10 is 100. And it's not so much that what's in here would be that, it's what's going in on this side. Because on the one side, we're looking at x minus 8 squared. Well, if x minus 8 was positive 10, it would give us 100. If x minus 8 squared was negative 10, well, negative 10 squared is 100, yes? It's not so much that the square root of 100 is our plus or minus. It's the fact that whatever we had before was a square. We're squaring it. We'll always get a positive number. Or a non-negative number.
We can't recognize it as a perfect square. Do you want us to still do that step that we did in the first part?
No. So if you could see at the beginning, you already have a perfect square trinomial set up, we can go straight to factoring into the set of parentheses squared. But at this point here, this is not our final answer.
Yeah.
We have to simplify it.
Hey, Potter, please come to the office. Hey, Potter, please come to the office.
Because we can add those together. 8 plus 10 would give us 18. 8 minus 10 would give us. And that's our answers. That's all we have to do for this year. Yep. And it does work out because negative 2 minus 8 would give us negative 10. Squared would give us 100. 18 minus 8 would give us 10 squared, which is 100. So it does work out. So is this one here a perfect square trinomial?
Yeah. 3, but 9 divided by 8. Wait. 3 times 3 is 9. You add 3 of the same is 6.
Let's see here. Let's factor this. Well, since it's positive, the constant term is positive, the signs are the same, and they match the sign of the middle term. So we'd have negative and negative. X squared would be x and x. And if we want them to be the same, we do have a factor of 9 that would be 3 and 3, yes? Which would be negative 3x minus 3x, which gives us negative 6x. Hey, that's what we wanted, yes? And since it's the same thing, I could rewrite this as x minus 3 squared is equal to 1. Now, we could have gone through and moved the 9 over, like we did with our steps at the first one, 2 spaces. And if we did the b over 2 squared, it would actually come out to be 9. Because 3 divided by, or 6 divided by 2 is 3. 3 squared would give us back to 9, yes? So there are some that are set up this way. Then what do we need to do next? We need to take the of both sides. And we get x minus 3 is equal to plus or minus 1. Plus or minus 1, because we could have one or the other. And then last but not least, we need to add 3 to both sides. And when we add 3 to both sides, we get x is equal to 3 plus or minus 1. Now, when you're solving these here, the main question when we get to this point here to yourself is, can I add these two numbers together? Can I directly add them together? Because we can do 3 plus 1 and we can do 3 minus 1, yes? Okay, we need to simplify this. Well, 3 plus 1 is? 3 minus 1 is?
What does it look like in that?
Uh, so when we have radicals, or I'm going to go into more, I'll do a new slide with this here in a second. But before we get into that, are there any questions on this one here? Are we good with how we got down to the answer? Yes? Okay. Now, looking at some of the ones where we can't, would be if we got an answer like 2 plus or minus 3i. Because we can't combine those. Those are not like terms, correct? Now, big ideas math is still going to give you this here, possibly 2 x's to put your answer in. Well, what would be one of these? It would be 2 and so if it gives you 2 spaces, this is most likely what it's looking for. Now, on the test, I will take the plus or minus. You're not going to have to rewrite it as 2 different answers. I'll take the plus or minus. But on big ideas math, most likely it's going to want you to split this up. The other case is we can have something like this here, because the square root of 3 is an irrational number. It's a non-repeating, non-terminating decimal. So really, I have 2 things multiplied together. I can't do just 1 plus 4 square root of 3. We can't just add those. So this here would be a case where we stop, because we can't really add these together. Questions on this here? Let's see. Okay. I want to do. How do we feel about these here? How do we feel about this? Doing these steps with completing the square. We feel comfortable with this? Yes. Or we can do it at least 1 time on the test. 1 or 2 times. Okay. We're going to look at this one here. So the steps are the same. We just have to do one thing first. Is A equal to 1? No. If not, make it so. How can I make the number in front of x squared be 1? Well, times it by 1 would give us the same thing. If I said, is 3x squared divided by 3? Well, 3 divided by 3 is 1. We have to do this to every term. 3x squared divided by 3 would give us x squared plus 12 divided by 3 would be x. 15 divided by 3 is 0 divided by 3 is 0. Any questions on this so far? Now, at this point here, you may be saying, hey, this factorable, we can factor it. Well, it actually doesn't work. Because our middle term would actually be 6 if we tried to factor it. It doesn't work for this here. So is A in front of x squared, is the number in front of x squared 1? Yes. Okay, now we can move on to step 2. Get the constant term by itself and leave 2 spaces. So we're moving the constant term to the other side. So for us, that would be, we would be doing what? We're going to subtract 5 from both sides. When we do that, we are left with x squared plus 4x plus a blank equals negative 5 plus a space. Now again, I'm going to move this over a little bit. so that we can find the value of c, so that we have a perfect square trinomial with our x squared and 4x. Now, what is the value of b? And it would be positive. It would be a positive 4 because it's plus 4x. Now, 4 divided by 2 is, and 2 squared is. So the perfect square trinomial that we're looking for is x squared plus 4x plus 4. Now, if we rewrite x squared plus 4x plus 4 as a set of parentheses squared, we would have what? X plus 2 inside the parentheses. Negative 5 plus 4 is negative 1. This here. Any questions on how we got to this point here? Okay. What do we do next? We square root both sides. When we square root both sides, the square root and square cancels, leaving us with x plus 2 is equal to plus or minus. What is the square root of negative 1? Well, we won't write 1i. Because again, I is equal to the square root of negative 1. I is the square root of negative 1. So we don't write 1i, we just write I. There's nothing wrong with 1i, but we just leave it as I. Now what do we need to do next? And according to number theory, we put the negative 2 in front of I. Now, big idea of math is probably going to want this as written out as 2 separate answers. I will take the plus or minus version, especially on the test. But big ideas math is probably going to want it split up into 2 forms, into its 2 forms. So negative 2 plus I and negative 2 minus I. Those are our 2 answers for this here. Questions on this here? Any questions on anything we've done so far? Yes.
Phi symbolizes a negative number. Why wouldn't you change the subtraction to plus?
Well, really what this is saying is that x is equal to negative 2 plus. And that's an excellent question. Because we know that it's negative 1. We know the negative 1's in there. But sometimes, it's easy to forget about this radical, trapping it on the inside. But yes, no, this is kind of why, because I is the square root of negative 1, it's trapped inside. That's why I wouldn't change the sign. Any questions on any of this here? Let's see here. Now, having a as a value different than 1 is not too bad. Would you all agree with that? Well, at least actually, I will tell you this. It's not bad for the ones I'm going to show you. It's not bad for the ones I'm going to show you. And we're going to do these here. Thank you. I've done that before. I paused it and then didn't restart it and finish the class. So the first thing we need to do for this problem is we need to divide it by negative 3. And thank you. And that's because we need the negative 3 because, again, our first step is a equal to 1. And not just 1, it has to be positive. We need it to be positive 1. Now, negative 3 divided by negative 3, well, that will be positive 1. Negative divided by a negative would be a 6x, because 18 divided by 3 would be 6. And then we have plus equals 0. And again, this thing's not factorable. Because if it was, it would mean somewhat, is x squared, the numbers with x squared doesn't help us to multiply to give us the middle term. So we're saying what factors of 2 would add together to be 6? Are there any factors of 2 that would add together to be 6? Well, what are our factors of 2? 1 and 2. The most they'd add up to be would be 3, yes? It's not going to work. That means that this here will not have real solutions. So we have to use completing the square. Yep. So we're going to subtract 2 from both sides. We get x squared plus 6x plus, we leave a spot, is equal to negative 2 plus a blank. And we will get real solutions for this here. They just won't be rational solutions. So what's the value of b? So we have 6 divided by 2, which is? Now we have a perfect square trinomial. Any questions on how we got to the perfect square trinomial? We good with this here? Okay. So what's going to go in there with x? Square root both sides. This and this. So we, plus or minus the square root of 7. Now 7 is a prime number, yes? The only products of 7 and 1 in itself, 1 and 7 are the only factors. So it is prime. So we can't simplify it. There's no way to simplify it. Now the last thing we need to do is we need to subtract 3 from both sides. So yet x is equal to negative 3 plus or minus the square root of 7. You get this here. Now again, in big idea of math, it's going to want you to split those apart. So x is equal to negative 3 plus the square root of 7, and x is equal to negative 3 minus the square root of 7. Yes? Any questions on any of these here? How do we feel with these here? We feel good? Let's do the next one. Before I move on, are we good to move on to the next problem? Yes? This one here. So this one looks different, and we're fine. We're fine working this here. Because if we were able to factor or use graphing or the square root method, well, we can't because there's a middle term. We can't use square root method. But if I wanted to factor or graph it, I would need to get everything on the same side. But here, we're determined, or actually if we're going to use the equation we'll use tomorrow, we would need everything on the same side. But I can leave it as this here, because what do we do in step 2? We get the term by itself. Is the constant term by itself? Yeah, it's already on the other side, isn't it? It's already by itself. So I'm going to leave it. Since the constant term is already by itself, I'm going to leave it over there. I'm not going to do anything with it. Now, if these two had been switched, if the constant term was with x squared and the term with x was on the other side, then we need to move it. But looking at this here, step 1, is a equal to 1? What do we need to do? What do we need to do to make it so? We need to divide everything by 4. Because 4x squared divided by 4 would be x squared. 32x divided by 4 would be negative just as a, I'm going to add this little bit. You need to really get x squared and x on the same side. They really need to be on the same side of the equation. We haven't come across one yet. I don't think we will. But if x squared and x, those two terms, whatever the numbers are, aren't on the same side, you need to get them there by adding or subtracting. Because really, we need x squared and x on the same side. And here we have it. We have x squared plus 8x plus, we can leave a blank, equals negative 17 plus, we can leave a blank. Because we need those two terms on the same side or with each other. And for these here that we're doing, we need the constant term on the other side. And yes, if you're wondering, well, we don't have to have it set up that way. We could really group x squared and x and do completing the square with just those two terms. It is possible. But what we're doing, this is the steps we'll do. Now we need to find c to make this a perfect square trinomial. So the value of b in our case is, we're going to have 8 over 2 squared. Well, 8 divided by 2 is? And 4 squared is? Any questions on any of this here? Any questions on any of this so far? So x squared plus 8x plus 16, I could rewrite this as x plus 4 squared. Negative 7 plus 16 would give us negative 1. What do we need to do next? Square root both sides. Any questions on any of this here so far? Last thing we need to do is we need to subtract 4 from both sides, which gives us x is equal to any questions on any of this here? Then this here is completing the square, yes? And any time I use completing the square, I will always get solutions that work, yes? I will actually not solutions that work. Any quadratic equation that I use completing the square on will always give me an answer. There's not going to be a case where it doesn't give me an answer. Did y'all agree with that there? Because we've seen multiple cases where this has worked every single time, yes? And what is a quadratic? It always comes in the form of ax squared plus bx plus c, yes? This is a quadratic. This is what we call a quadratic, yes? And what did we say? If we use completing the square, we will always get a solution, yes? This is the general form for any quadratic, yes? Okay, I'm going to complete the square. I would not write this down. As well, actually I got to step ahead of myself. Because here a is not 1. The term in front of x squared is not 1, so I have to divide to get it to be 1. Then I would subtract c over a. Because if I find c for this here, so c is equal to, our middle term was b over a, so this would be b over a over 2 squared. That'd be b over 2a. Which ends up getting us this here. Now, I'm not worried too much about the a squared equals that needs to be negative, b squared minus 4ac all over 4a. And we square root this, so we'll get the square root of b squared minus 4ac. That should be 2a squared. Simplifies this here if we subtract any quadratic, so this solution is this here is the quadratic formula. You will never have to do any of those steps. But as we said to begin with, completing the square will work with any quadratic. It'll give me the solutions to any quadratic that I want. Yes? I just use it on a general equation. So if I know the values of a, b, and c, we can plug them in. The quadratic formula. So from here on out, so what we'll do tomorrow is this formula. We'll use this formula. Now all I have to do is plug in the values of b, a, and c, simplify, and we get the answer. And we'll get the answer. But we'll cover that